Students, if I have to explain the reaction between zinc and hydrochloric acid, I can simply say that zinc reacts with dilute hydrochloric acid to gives you zinc chloride and hydrogen gas is evolved. Just see, this sentence is too long to write. So students, instead of representing the chemical reactions in the form of sentences, we use equations. These equations are also known as chemical equations. So let us study what are chemical equations. Chemical equations. Students, actually these equations are of two types. First is word equation, then we come to chemical equation. So let us first of all study about what are word equations. So, what are word equations? Students, these word equations actually links the reactants and the products. Their names are actually linked here. Now students, if I say that magnesium reacts with oxygen to gives you white colored powder of magnesium oxide, this is a very big sentence. So instead of writing this sentence, I can just represent that in the form of word equation. Word equation links the name of the reactants with that of the products. So what I can write, it links the name of the reactants with that of the products. So students, if we have a reaction between magnesium and oxygen to give you magnesium oxide, I can simply write the name of the elements. So the first element which reacts here is in the reaction magnesium. Magnesium reacts with oxygen. So I can write the other reactant is oxygen. The react thing I can show by this plus sign. So this shows that magnesium reacts with oxygen to give you magnesium oxide, which is a white colored powder. Now students, these two things which are written on the left hand side, these are the reactants. So students, these are the reactants, and instead of writing the whole sentence, we can just write the words or names of these chemical species. So here magnesium reacts with oxygen to give you magnesium oxide. And students, the one present on the right hand side is known as product. So here magnesium oxide is the product. Let us take one more example. Let us take the example of zinc reacts with sulfuric acid to give you what? It gives you zinc sulfate and hydrogen gas is evolved. Now students, you can clearly see here the two species which are present on the left hand side are the reactants. That means zinc and sulfuric acid are the reactants. These two are reacting and giving you zinc sulfate and hydrogen gas evolved. And these two are the products here. Now students, what is this actually representing? These actually representing the reaction. Now in this reaction, the names or words of the species is there. Now students, this plus sign shows that this is the reaction between magnesium and oxygen. This arrow actually separates the reactants from the products. And students, this arrowhead actually arrows towards the product side. So this shows that this arrowhead actually shows that zinc and sulfuric acid react to give you zinc sulfate and hydrogen gas is evolved. I hope students this word equation is clear to you. Now students, this representation of the equation reaction in the form of word equation is not that short. So instead of using the word equation, we actually use the symbols and formulas of the species, and the equation in which the symbols and formulae are used, that equation is known as chemical equation. So students, let us know about the second type of equation, that is chemical equation. So what is a chemical equation? Students, chemical equation represents the chemical reaction in the form of symbols and formulas of the species involved in the reaction. Now students, if we have the example, let us come on this side. We have the reaction between magnesium and oxygen to give you magnesium oxide. Now once we are familiar with the symbols and formulae of the species, we can, instead of writing the words or names, we can write down the symbols. So the magnesium symbol is Mg. Instead of writing the whole name, I can simply write the symbol. Magnesium reacts with oxygen. Oxygen is present in the form of O2 molecule. So this is the formula of oxygen molecule. Magnesium reacts with oxygen molecule to give you magnesium oxide. And the formula of magnesium oxide is MgO. I hope students this is clear to you. Next example we took was the reaction between zinc and sulfuric acid. Instead of writing the words, we can write the symbols and formulas also. So the second can be zinc reacts with sulfuric acid. Sulfuric acid is H2SO4. It gives you zinc sulfate and hydrogen gas is evolved. And this arrowhead points towards the product side. So students, this is the simplest, concise and short way of representing a chemical reaction. So students, a chemical reaction in which the symbols and formulae are used is also known as symbol equation. Now students, what is this chemical equation? It is the schematic representation It is representing what? It is representing a chemical reaction. So yes, it is a schematic representation of a chemical reaction by using symbols and formulae of substances involved in the reaction. Now I hope students, two type of equations, word equation and chemical equation is clear to you. Next students, we will study what are unbalanced and balanced equations. Now students, let us study what are balanced and unbalanced chemical equations. So let us study about balanced and unbalanced equations. These are chemical equations we are talking about, that whether the chemical equation is balanced or not. Now students, let us study this with the help of example. Let us take the first example of a chemical equation which is representing the reaction between zinc and sulfuric acid. Sulfuric acid is H2SO4. Now when there is a reaction between zinc and sulfuric acid, it gives you zinc sulfate and hydrogen gas is evolved. You're familiar with this reaction? Now students, let us see whether this equation is balanced or not. By the word balanced, we mean that the number of atoms of each element should be equal on the reactant side as well as on the product side. Now to check whether this reaction equation is balanced or not, let us write down the symbols of various elements involved in this reaction. So various elements are, one is zinc, other we have hydrogen element is also there, sulfur is also there and oxygen is also there. Now let us count the number of different elements in the reaction side as well as in the product side. So in reactants, how many atoms of each element are there in reactant side? In products, first coming to zinc atom, let us count the number of zinc atoms in the reactant side. As you can see, there is just one atom of zinc. So I can write 1 here. Coming on the product side, let us come on this side, count the number of zinc atoms. There is just one atom of zinc. So I can write 1 here. Next, coming to hydrogen. Let us count the hydrogen atoms on the reactant side. As you can see here that there are 2 atoms of hydrogen on the reactant side and 2 atoms of hydrogen on the product side. Coming to sulfur atom, let us see how many are there in the reactant side. There is just one sulfur atom. So let us write 1 here. And there is just one sulfur atom in the product side as well. Coming on the oxygen atoms, the number of oxygen atoms in the reactant side, let us see how many are there. There are 4 atoms. So I can write 4 here. Coming to the product side, there are 4 atoms of oxygen as well on the product side. So students, when you see that the total number of elements, the atoms of each element is same in the reactant side as well as in the product side. And when this is the case, such equations are known as balanced equations. So the above equation is balanced. So the equation representing the reaction between zinc and sulfuric acid giving you zinc sulfate and hydrogen is a balanced equation. Let's see a few more examples. Second example, I can take the decomposition of calcium carbonate. If we have calcium carbonate with the formula CaCO3, it decomposes to give you calcium oxide plus carbon dioxide gas is released. Now let us see whether this equation is balanced or not. Let us count the number of calcium atoms on the reactant and product side. There is one calcium atom on the reactant side and one in the product side. So calcium atoms are balanced. Coming to the carbon atom, one atom of carbon in the reactant side and one on the product side. That means carbon atom is also balanced. Now last we are left with oxygen atom. 3 atoms of oxygen in the reactant side, 1 plus 2 atoms of oxygen in the product side. That means this equation is a balanced equation. Third example, equation representing the reaction between carbon and oxygen giving you carbon dioxide. Now students, I hope it is clear that if I say that this equation is a balanced equation because there is one atom of carbon in the reactant side and one in the product side. 2 atoms of oxygen in the reactant side and 2 atoms of oxygen in the product side. So these 2 chemical equations are balanced. Balanced chemical equations. Let's come on to another example. Now fourth example I'm taking is the equation representing the reaction between hydrogen gas and oxygen gas giving you water. Now let us see whether this equation is balanced or not. For that, let us write the elements involved in the reaction, hydrogen and oxygen, in the LHS or the left hand side, which is representing the reactants, in RHS, which is representing the product side or the right hand side. Now students, how many hydrogen atoms are there in the reactant side or in the left hand side? Number of hydrogen atoms are 2 in the reactant side. So I can write 2 here. Let us count the number of atoms of hydrogen in the product side or at the RHS. There are 2 atoms. This means the number of hydrogen atoms are balanced. What about oxygen atom? There are 2 oxygen atoms in the reactant side and there is just 1 atom in the product side. So this clearly shows you that oxygen atom in this reaction, in this equation, is not balanced. Now students, it seems like we took 2 atoms of oxygen in the reactant side and we got just 1 atom of oxygen in the product side. So it shows that similarly somewhere here 1 atom of oxygen has been destroyed. But that cannot be the case because we have already studied about law of indestructibility of matter. That matter cannot be created nor be destroyed. So this cannot be the possibility, and this representing this equation in which the total number of atoms of each element are not same in the reactant and product side, such equation is known as unbalanced chemical equation. So above equation is unbalanced. And students, unbalanced chemical equations are also known as skeletal equations. Skeletal equations. Let us take one more example. We generally study the reaction between magnesium and oxygen to give you white powdered magnesium oxide. So the chemical equation representing that is magnesium reacts with oxygen to give you magnesium oxide, which is a white colored powder. Now whether this reaction is balanced or not, whether this equation is balanced or not, let us see. There is one atom of magnesium in the reactant side, one in the product side. But there are two atoms of oxygen in the reactant side, but one on the product side. So that means this equation is unbalanced. Students, balancing of a chemical equation is very necessary. So next, let us study the balancing of chemical equations. Now students, let us study how to balance a chemical equation. So let us learn about balancing of a chemical equation. Balancing of a chemical equation. So students, let us write down the steps to balance the chemical equation. First of all, we will take the skeletal equation, that is the unbalanced equation. Students, skeletal equation, I told you before, is an unbalanced equation where the number of atoms of element are different on the RHS, the reactant side and the product side. So students, let us understand this with the help of example. Let us see a chemical equation which is representing the reaction between calcium and water. Now students, when calcium reacts with water, it gives you calcium hydroxide and hydrogen gas is evolved. Now students, this is a skeletal equation. Let us see how. There is one atom of calcium and there is one atom of calcium. So calcium is balanced. Let us coming to oxygen atom. There is one atom of oxygen in the reactant side and there are two atoms of oxygen in the product side. That means this reaction is unbalanced and we need to balance this equation. Now students, next step is to enclose the formula of the species in the brackets. Students, enclosure of the formula in the brackets is done actually at the very initial stages of learning of balancing. Let us put these formulas or symbol of the monoatomic element. Calcium is put in bracket. Then we have water. Put the formula of water also in bracket. Next, it reacts to give you calcium hydroxide with formula CaOH whole twice. Put this also in the bracket and hydrogen gas is evolved. Now students, putting these things into bracket, it shows that during the balancing we cannot change anything inside the box. Now students, next is to count the number of atoms of different elements in the reactant as well as products. Now students, I need to list or count the number of atoms of different elements present in the reactant side and product side. So let us see how many elements are there. There are three elements: calcium, hydrogen and oxygen involved in this reaction. So let us see. There is calcium atom, hydrogen atom and oxygen atom. In the LHS, we will write the number of atoms of the reactants, and in the RHS, right hand side, which is representing the number of atoms on the product side. Now let us see how many calcium atoms are there, hydrogen atoms are there, and oxygen atoms are there in the reactant as well as in the product side. Let us count. There is 1 atom of calcium in the reactant side and there is 1 atom of calcium in the product side. So in the both sides I can write 1. Let us coming to hydrogen. Count the number of hydrogen atoms. There are 2 atoms of hydrogen. Going to the product side, there are 2 atoms of hydrogen plus 2 atoms of hydrogen, giving you 4 atoms of hydrogen. So 2 are there in the reactant side and 4 are there in the product side. We are left with oxygen atom. There is 1 atom of oxygen in the reactant side, so I can write 1 here. Count the number of oxygen atoms here. There are 2 atoms of oxygen. So I can simply write 2 here. Now students, next thing, how to balance. Let us see. Now students, fourth step is to select the formula of compound which is most complex or the compound which has biggest formula. Let us see students, in this equation the formula of which compound is most complex, that is of calcium hydroxide. These are the simple formulas: calcium, water, hydrogen. The most complex is that of calcium hydroxide. So in this we have selected calcium hydroxide. Now students, from the selected formula we need to balance first the atom which is present in maximum amount. The maximum number are present. Here you can see the number of oxygen and hydrogen are same. So we can actually start with oxygen also. So 5 steps is actually balancing start. Now students, in this we see we can start the balancing with oxygen. Now students, when we start the balancing with oxygen, let us first of all write down the skeletal equation again. The skeletal equation we have calcium enclosed in brackets. We put water also in the brackets. It gives you calcium hydroxide and hydrogen gas is evolved. Now students, we need to balance. We have chosen oxygen to start with. There are 2 atoms of oxygen in the product side. We need to balance this, and students, you can see here that there is 1 atom of oxygen. As we have put the formula in the bracket, in the boxes, we cannot change anything inside the box. So simply to balance oxygen atoms, I can simply write 2 here. Now students, let us count the atoms again. Calcium is 1, calcium is 1. Let us see about oxygen. Oxygen is balanced or not? There are 2 atoms of oxygen and 2 atoms of oxygen in the product side also. That means oxygen is also balanced. What about hydrogen? We are left with hydrogen now. 2 into 2, 4 atoms of hydrogen on the reactant side, 2 plus 2 on the product side. That means hydrogen atom is also balanced. And now when the atoms, all the elements are balanced, that means that this is a balanced equation. So students, this is a balanced equation. I hope students, the steps taken for the balancing are clear to you. And students, this method of balancing is actually simply known as hit and trial method. So this is a hit and trial method of balancing of chemical equation. I hope students, how we balanced this reaction is clear to you. Next, for the further clarity, let us take few more examples.